Last type of graph we're going to cover here in the first chapter of the book is a frequency distribution that's going to organize data in a way that we can create a histogram. Histogram is very similar to a bar graph, except it's for quantitative data instead of qualitative data. And there's going to be a few more rules in how we put together the bars, where we want the first bar to be touching the axis, we want additional bars to be touching each other, but really it's going to be creating this frequency table that leads us to be able to create the histogram. So, when we're constructing a frequency distribution, first thing we need to do is determine how many classes or categories should be in the distribution. This is kind of a difficult step. There's a formula that we can follow in order to figure out, once we know how many classes, what the class width should be. And in general, I tell students, let's just go with 5 classes, because I feel like having a set number like that makes it easiest. If you were in the real world trying to organize data in the best way, there might be data that's just so vast that putting it into 5 classes doesn't really make sense. There also might be times where you want a smaller number of classes because you wanted to really show the distinctions between set lines in your data. So even though I'm going to go with 5 just to give you guys a baseline and something to be used to when we're just learning at first, there are reasons that you would go with different numbers of classes before creating this frequency distribution. We're going to use the 5 classes and then knowing the min and max in a formula in order to create an appropriate class width. Once we know that class width, we'll be able to create the class limits. Then we're going to use those class limits to count how many data points fit into each class. And finally, we'll be able to calculate relative and cumulative frequencies once we know those frequencies within each class. So if this is all jargon to you and you don't understand a word I said, don't worry, I'm going to walk you through everything you need to do for this. First off, I'm going to take a raw data set. Again, this is fake data I made up, but this gives us something to work with. So before it's organized into classes, all we have is a collection of numbers without context. Let's pretend that we asked 20 randomly selected high school students how much they make per month at part-time jobs and got the following data. So I went up to 20 people and high school students recorded in order what they said as their answer. First person told me they make $200 a month, next person 800, next person 0, and so on. Here they are listed by commas, everything that I got. So once I have my raw data, the first thing that I'd recommend is putting it into order smallest to largest. If I put this into order smallest to largest, I'd see that it happens a couple times, but $0 is the least amount of money that anybody made. And if I'm looking for the largest amount of money that anybody made, it's this $1,500 right here. So that would be my min and my max. Minimum of $0, maximum of $1,500. There's typically between 5 and 20 classes in a frequency distribution, depending upon what a researcher believes will display the data most clearly. For the purpose of this course, you'll be given a suggested number, specifically 5. Pretty much, it's possible that in a same-page online assignment they give you a different number of classes than 5, but I try and stick to 5 in the assignments, and that's really what I want you to use for the project that you're going to do, where you're going to create a frequency distribution. So 5 is just kind of my default number for these. To begin determining the class width, you want to take the range of values, largest minus smallest, and divide it by the number of classes. So when we looked at our data, 0 was the least amount of money somebody made, 1,500 was the most. That's where I'm getting this 1,500 minus 0. Largest number in my data set minus smallest number in my data set. Divided by 5, again, I just decided I want to have 5 classes because I feel like it's a nice clean number that I've used in the past. That would give me a class width of 300. 1,500 minus 0 is 1,500. If I then divide by 5, I get 300. 300 is a nice round number. I'm fine with 300 and I'm going to use it. But this formula could give me a number that's not as nice. If, for instance, I came up with 289.4, I would probably round that to 300 so that my classes just had numbers that were easier to digest, easier to look at. Similarly, if I did this formula and I got 11.3, I'd probably use 10 as my class width. Again, it's just so that people who are viewing it see numbers that kind of have natural cutoffs in their head. So things that are multiples of 5, multiples of 10, multiples of 100, things like that, are probably what I want to use if I can round to something close. So the next thing I have to do is find the class limits and class boundaries. This is a lot of words, but let me walk you through what it's really saying. First thing I do is I start at this minimum. So I think of the smallest point in my data set. We said 0 was the smallest point in our data set. So I'm going to write a 0 for where the first class is starting. What I now want to do is find where each subsequent class is starting. To do that, I'm going to add the class width to the previous class. So if my first class starts at 0, the next class starts at 0 plus 300, which is 300. So my next class, 0 plus 300, gets me to 300. I keep going with this pattern and add 300 to the one that came before. So since my second class starts at 300, when I add 300 to that, I'll get to 600. My third class starts at 600, when I add 300 to that, I get to 900. Finally, I get to 1200 for my final class. Now that I know where every class starts, I have to figure out where the classes end. Depending upon how your data is organized, you want to make it so that it's the last number that can come before the new class that's going to start below. So for my data, when I ask them how much money they made at their job, I'm going to assume nobody's going to say in 50-cent increments. Everybody's going to give me whole dollar increments. So for that reason, if my first class starts at 0 and my second class starts at 300, then my first class can end 1 before 300. 1 before 300 is 299. So if I make my first class go from 0 to 299, nothing will overlap with my second class, which can then go from 300 to 599. Really all I'm doing is taking the class that comes after and I'm subtracting 1 from it. So 1 less than 300 gets me to 299. 1 less than 600 gets me to 599. 1 less than 900 gets me to 899. And 1 less than 1200 gets me to 1199. The last class will be a little different. Basically, wherever I'm starting the last class, I want it to end at my maximum value. So it'll be a little larger than the other classes in this case because it goes to 1500, not 1499. If you round it, it could be even a greater discrepancy in that last class, but basically you just need to make sure that last class includes your largest value. What we've really done now by calculating where the classes should start and where the classes should end is we found our list of here's the different categories we're going to place everything into. We're going to take the raw data and we're going to say how many points fall between 0 and 299. Then we're going to say how many fall between 300 and 599, between 600 and 899, 900 and 1199, and 1200 and 1500. These are class limits listed as lower dash upper. So if instead we were asked for class boundaries, which happens in the homework, you would just list the lower class limits separated by commas and include the last upper class limit. In this case, I would list 0, 300, 600, 900, 1200, 1500. So again, these 5 are all the lower class limits I found, and then as the last class boundary, I want to include that 1500. Once we know what our classes are, so here's the established classes, the next thing you want to do is go back to your raw data and see which ones fit into which class. So for 0 to 299, they pulled out 1, 2, 3, 4 times, 5 times that 0 happened. 1, 2, 3, 4, 5. They pulled out that 200 happened here, 200 happened here. Nothing else in this list falls between 0 and 299. So when counting up the data points that fall in that class, there's 7 data points, therefore it has a frequency of 7. So the goal is set your class limits by first calculating the class width, then setting lower class limits by minimum plus class width 5 times, or really 4 times because you have the starting point. Set upper class limits as just 1 less than the next class, and the final one is your maximum. Once you have that, you now have your categories to fit things into. Go back to your raw data, see how many fit in each category. This part I'm not really going to include in my table. This part is just seeing how many fit. What actually goes into my table is this. So we're going to start making that table. This is what we're building towards. You will have to make one of these in your Excel project. You also have to answer questions about these and do parts of this within your online homework and possibly on the test. So once I filled in the classes, I counted how many fit into each, and here are the frequencies. From these two columns, I can use formulas to get to this column, and this column. One by one, I'm going to show you those formulas and how I would fill in those columns. So the first one, the class midpoint, is entirely based on these two class limits. All I'm going to do is add lower class limit plus upper class limit and divide by 2. Basically, the average of those two numbers is the midpoint. So this is showing that for the first one, it would be 0 plus 299 divided by 2 gives me 149.5. That's why 149.5 is written in as the class midpoint. I could then do 300 plus 599 divided by 2, and that would give me 449.5. That's one way to look at this and one way to do it. You can always just keep adding together the two class limits, lower and upper, and dividing by 2. But you also could see a pattern developing. Really, all that I'm doing each time is adding the class width. So to get from 149.5 to 449.5, I'm really just adding 300. Same thing to go from 449 to 749, and to go from 749 to 1049. So each of those is really just plus the class width. That said, the final class won't work that way. Because the final class went to a little more, this doesn't follow the just add 300. You would have to do this where you add these two together and divide by 2 in order to get this number. So you can follow that pattern for everything up until the final class. Second thing we need to do from this data is calculate a relative frequency. Basically, the total number of people I asked goes on the bottom of the fraction. So you can get that either by adding together all these frequencies. 7 plus 5 is 12, plus 3 is 15, plus 2 is 17, plus 3 is 20, or from remembering in the first place that you were told there were 20 data points that you asked 20 people. Whatever the case, once you know what the total is, you just take the frequency, divide it by that total, and get an answer. Usually relative frequencies are displayed as decimals, so here I multiplied by 100 and made them a percent. They do that sometimes, I believe, in your book, but I think it's more likely you see this just listed as 0.35. So for each of these frequencies, I divide by the total. 7 divided by 20 gives me 0.35. 5 divided by 20.25. 3 divided by 20.15. 2 divided by 20.10. And 3 divided by 20.15. The last thing is a cumulative frequency. What a cumulative frequency tells me is how many things are in this row and all the rows above. So for the first row, nothing's above it. I can just write over 7 goes over here as 7. In the next row, there's 5 more. If I take that 5 and add to what came above 7, 5 plus 7 gives me a total of 12. I'm then adding 3 to that. 3 plus 5 plus 7 is 3 plus 5 is 8, plus 7 is 15. Or I can just see it as the row that came before 12, plus what I'm adding now, 3. 12 plus 3 is 15. When I get to the next row, I'm adding 2 more. 15 plus 2 is 17. Then I'm adding 3 more. 17 plus 3 gets me to 20. It should always be the case that your final row has a cumulative frequency that's equal to the total number of people you asked. So if I didn't get to 20 for this last one, something went wrong in the math I did above. This is the final table that we're trying to put together from our original raw data. So there's a lot of steps here. Basically, I needed to, from the beginning, figure out what categories do I want to fit stuff into. To do that, I used the formula for class width. I then created my lower class limits, my upper class limits, which created my classes. I counted how many data points fit into each class, which created my frequencies. And then I used this information to calculate these 3 columns. Once we've got everything together, we can now make histograms. The histogram is going to have these as the labels between the points, and it's going to display in bars how many frequency were in each class. It can be done as a relative frequency histogram or a frequency histogram. Both are valid. Really, all it does is change the y-axis. So, histograms are made directly from frequency tables. They look a lot like bar graphs with a key distinction. The bars touch each other, and they touch the vertical axis. So the first bar starts touching the axis. You still need to label the axes and to label the class limits of individual bars. Let's construct a histogram from our frequency table dealing with student money earned from part-time jobs in high school. So here's what it looks like when I do it in Excel. Really, what Excel is telling me here is the endpoint. So you might see this in your Cengage homework as well, where it's telling you this is happening. Really, it should say at 300. So 0 to 300 is this bar up to 7. I'm sorry, 0 to 299 is this bar up to 7. 300 to 599 is this bar up to 5, and so on for each of the other bars. Over here, it's labeled frequency, or how many times did the thing happen. And here, I have a title of high school monthly earnings. I might want to down here say dollars earned per month or something like that. But for the most part, the key things I want you to take away are that you have a vertical axis labeled frequency, that the bars all touch each other, that the first bar touches the axis, and basically it represents how many fell into each class. Here's a relative frequency histogram that I made by hand, so basically it's the same information. The only difference is here I should have something saying relative frequency, I really should have written in, and it's by the decimals. So my highest relative frequency was 0.35. For that reason, I decided to go by 0.05s up to 0.40. This bar is at 0.35. This bar is at 0.25, 0.15, 0.10, and 0.15. If you were answering a proportion question from a histogram, which is something that you are asked to do in the homework, histogram above is showing the relative frequency of the number of items sold at a garage sale. If I wanted to know the proportion of garage sales that sell between 1 and 6 items, I would look at the first bar. So basically, I'm saying that none of the garage sales sold 0 items. So the first class had a minimum of 1. It went from 1 to 6 items, and it looks like 25%, or 0.25 is a relative frequency, fell between 1 and 2. So the proportion between 1 and 6 is 0.25. If instead I'd been asked the proportion between 1 and 11, so between 1 and 11 encompasses these 2 bars. Between 1 and 11 would be this 0.25 for the first bar, plus I'd add the second bar, 0.1875. If I add those together, 0.25 plus 0.1875, I'd get 0.4375 as my total proportion. So when they ask you these proportion questions from the histogram, think about which bars are included, add together the relative frequencies of those bars. So here's 3 more questions for you to try on your own. Again, feel free to pause the video, attempt them on your own, but I'm going to go ahead and show what the answers would be. What proportion of measurements are between 16 and 21? Well, between 16 and 21 is here, which has a line going to here, 0.0625. If I'm then asked what proportion of measurements are more than 26, well, here's 26. More than means to the right of, so that would include this bar and this bar. This bar is occurring at 0.1875. This bar is occurring at 0.0625. So the total, when I add these together, is 0.25. Finally, what proportion of the measurements are between 6 and 21? Here's 6, here's 21, so that would include this bar, and this bar. You see I add them together here, and I get an answer of 0.375.